trig in general. Okay, so I know we've been working with trig and that type of things, and I know we've talked about SOHCAHTOA and all of that wonderful jazz. All right, but there's a few other things that we want to try to look at and take into consideration. Okay. First of all is understanding that trig is not just it's their ratio values. Okay, so we have the sine, let's see, which is the specific relationship of the opposite side over the hypotenuse. We also have cosine, which is the adjacent side over the hypotenuse. And then, of course, the tangent of theta, which is, of course, the opposite side over adjacent side. Okay. All right. Well, let's see what we can do to try and help clear up some of the things. All right. So first of all, we have to think about a right triangle. All right. So when I say think about it, one of the things that we need to remember always is that we have the hypotenuse is always going to be opposite the 90 degrees. Okay. And that's not going to change. That's always going to be the case. So trying to determine opposite or adjacent is really the only thing that we're having to look at. And that's the comparison of those legs. So what I have up here on the screen is actually what we call a trig table. So back in the day, like when I was in school, and this is going to kind of date me a little bit, we had to actually carry a little trig booklet around with us, and the list of all the ratios for all the measurements of a right triangle were on this chart. Okay. So we would then get our little 4-function calculators, because back in the 80s we didn't have much else, and we would actually have to go look up these ratios off of this chart in order to use them to calculate, you know, into our, you know, to get values. So saying all that, understanding that these trig functions are actually a number, they're an actual numerical value and not just some fabricated, you know, assortment of things. All right. So let's just kind of, we'll take a comparison. I believe this is today. Oh, and also what I use with my class, so like I like to use these little triangles. They're kind of cute. Which is, this is the sine, is opposite. Oof, I can't write. Let me zoom in a little bit. That's going to make it a little bit easier to write. All right, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then, of course, tangent is opposite over adjacent. So anyway, it's just another little way of remembering the SOHCAHTOA. Okay. All right, so let's just kind of take a look first at this problem. This is number 1 off of yesterday's learning check. Okay. Also, a few more people have just signed on, so I'm putting the sign-in link in the chat. Oh, we still have more people joining us. Welcome in. Again, here, let me drop that. Sign in is in the link, in the chat link. All right. All right, so let's just kind of look at this real quick. All right. So we have here, and this is what I tell my students to do on a regular basis, okay? And it takes a little bit of practice, but just bear with it. So we want to identify, first of all, where is our hypotenuse in our triangle, okay? And in this particular triangle, here from the opposite side of my 90-degree angle is my hypotenuse. As you can tell, the values that are being given to us are not on the hypotenuse. We don't have anything on the hypotenuse. So let's take a look and see what is given to us. So we have our angle measurement, and the angle is 40. And we want to identify what the legs are in relationship to the that angle. All right. So 18 is opposite the 40-degree angle, and X is adjacent. Yes, what's the question?
That's a Toa
Yes,
or tan.
yes, correct. Very good. Because, and that's the other thing too about like the little triangles that I like to use with mine. You know, so it's like just right away we can kind of look at it and say, okay, I don't have the hypotenuse, so therefore it's going to have to be tangent. All right. So again, like you said, you're correct. The hypotenuse was not given to us, and so that immediately scratches the sine and the cosine and leaves us only with the tangent as an option. Okay. So we are going to set that up. So tangent of 40 is going to equal the opposite, which was 18, over x. Now, I had my kids were doing this the other day, and I was like, oh, this is what our calculators are for. Okay, but we want to make sure we're always in degree mode. But let's just talk about what is this ratio. So what we would do, and this is the way I would have to do it back in the old days, which was before calculators and before Silicon Valley, okay? So I have the tangent of 40. What I could do is then now I would go over to my table here. And as you can see at the top of the list, we have our angle measurement, our sine, our cosine, and our tangent ratio value. Our angle measure for ours over here was 40. So we're going to go down and look for the angle measure of 40. So here it is. We have 40 here. So now again, remember it's sine, cosine, and then tangent. So our tangent value is 0.8391. And of course, I can't see it. It's all the way over there. All right, so that actually has a numerical value. So we could actually rewrite that whole expression using that ratio. Okay. Oops, I don't want the highlighter. I need pen. Okay, there we go. So 0.8391 equals 18 over x. Okay. So now to solve, we would then put this over 1 because any whole number or any number is over 1, and then we would cross multiply. All right, so we end up with x times that whole decimal value equal to 1 times 18, which is 18. And then divide. And then we would use our calculator, which I don't have a good calculator on this particular computer. Let's see, hang on for a second. Has everybody signed in, or does anybody still need the sign-in list link? Did we get anybody else added in? Let me stop presenting real quick, and I'm going to actually share my whole screen instead of just that one. All right. Okay, I'm doing that so that we can, I can pull up a calculator and y'all can see it, okay? All right, so one of the things I did find out that even on our, can y'all see the calculator as well? Because those, I changed those, the way that the view was there. Now, the only thing that's kind of funky about the calculators on our computers is that, well, one, we need to make sure it's in degree mode. And since the degree right here is on, you can see that it should be there. All right, so it's on degree. And again, if I wanted to find out the tangent of 40, we would type in 40 and then tell it the tangent value. So again, off of our table, we only had the 4 digits, the 0.8391. So, but you can see that according to our calculator, that is a really big, huge decimal number. So our decimal values of these ratios is really, really huge. And nobody wants to memorize that many digits. And so that's when they programmed it into our calculator. Okay. So instead, we just go to our calculators and we type it in as we need to. So let me clear this. So now I would, but this calculator is kind of funky. All right, we got 18 being divided by, and I'm gonna open parentheses to make sure that it keeps track of what I've got going on, 40. And then I go to my trig function tangent and hit enter. And that is our answer. But of course, it's got all those decimals. So we find that X in this situation is, and my calculator ran away from me, 21.45. Okay. So again, we want to just leave it as the tangent. All right. So again, just remembering what we're dealing with when it comes to the, what is that value? What is it actually dealing with? I don't know. I Googled it. It's a trig chart. I just literally Googled it and went and pulled up an image. So it's actually just a trig ratio table or a trig table. You can Google it. All right. But of course, the thing is our calculators all have it programmed, which is the nice thing. Okay. Because that was the thing was that back in my day, we didn't have calculators, we didn't have cell phones. And so we had to have a little bit, we were excited when we had a solar panel on our calculator and didn't have to carry around batteries. Okay. So but understanding that these are ratios, that this is a value that can be, that's concrete, that's going to be out there, and we could look it up on the table. And we can actually do the opposite as well if we want to go and find a measure of an angle. And I'll show you how to do that here in a minute too. But again, we have a calculator, and we can use the calculator. Yes, what's your question, Iva?
So for the first problem, the formula you use, is that like the formula for everything? Like if it was
No.
cosine, would you use like cos, then the angle, then equal, then the number over x? Like, is that the formula for everything?
It's not, it's close. There can be variations, but yes, it's a proportion. You can think about it in the sense of it's a proportion. We're dealing with like similar triangles, but within a right triangle, everything is proportional. So we can set it up as a proportion, which is what I've done here. Okay, so I always set it up, and it's just kind of the pattern and the way that I teach it as well, is essentially we're going to have our trig ratio, and it's literally, we're just setting it up like this, like our what we defined up here, okay? But I'm putting my trig function over 1. Whoops, I was trying to move my screen. All right, we put the trig function over 1 and solve. All right, so for the missing side, that's only going to work for the missing sides. But yes, you're going to have to identify which ones we're going to use and go from there. We can do a few, we'll practice a few here real quick. All right, let me move some of these down and out of the way so I have a little more room. Okay. All right. So again, what we want to do is we want to identify our sides and our values. And from our 90 degrees is always going to be our hypotenuse. All right. This time they're giving us a hypotenuse and we have a numerical value on it. So we want to think about it in the sense of, okay, out of my trig functions, and again, I'm just looking at our trig functions that we have already identified up here. All right. From those trig functions, we have 2 that have a hypotenuse. We have the sine and we have the cosine that have a hypotenuse. So what we need to do now is determine our other side. Is it adjacent or is it opposite? Okay. So in this case, here's my angle, 49. So my x is actually adjacent to our angle, right? So therefore, again, referring back to our formulas, because that's what these are, they're formulas or they're ratios, they're ratios in that regard. We are going to want to use the cosine because again, what did we get? We had an adjacent side and we have a hypotenuse. Okay, so this one's going to be cosine. And of course, our ratio value is cosine of theta is going to be adjacent over hypotenuse. And again, it's when we do this and we set it up, we're going to cross multiply and solve it. All right. So again, cosine of 49 degrees is going to equal the adjacent side, which in this case is x, over our hypotenuse, which is 75. And again, cosine 49 is going to be over 1. So again, cross multiply. And we end up with x equal to 75 times the cosine of 49. Now, I do tell my students, be very careful, keep that cosine in parentheses, keep your trig function always in parentheses so that we can ensure that we don't get the numbers mixed up, okay? All right, so again, this time we're doing 75 times, open parentheses. And for our computer calculator like this or our cell phone calculator, sometimes you have to type in the angle and then tell it which trig function. And then it calculates it for us. All right, and hit enter. So we get that x is 49.2. And if you noticed when I was typing that in and I had put in the 49 with the cosine, it immediately draws out of its memory that ratio value. And we could go and look at our trig table and find it. So again, we were looking at the cosine of 49. So that's going to be up here. So 49 cosine 6.6561. And that's it too. So you can actually see that the numbers line up and they're rounded off. Okay. But again, luckily our calculator can handle all of those decimals and keep track of those decimals where we don't have to worry about it. Okay. All right. Y'all ready for number 3? Let's see real quick. All right, we have others that have joined us. Let me again drop the sign-in sheet into the chat. Here you go, there's the sign-in sheet. So those that just joined us, please don't forget to sign in. That way we can account for y'all. Okay. All right, y'all ready to look at something else? Another one? Okay. My stylus. All right, so for this one, again, my suggestion is always, and one of the things I tell my students always a lot too, any formula chart is going to have those trig functions on it. Okay, so make sure you have the trig functions somewhere handy when you're working through these things. Okay, so again, you just kind of want to keep that in mind. So again, that goes straight to sine is opposite over the hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is opposite over adjacent. Okay. All right, so looking at this one, we have, we want to again identify our hypotenuse, and 10 is our hypotenuse. So that tells me right away that we are going to be working with cosine or sine, all right, because we have a hypotenuse. And our angle is 36. You're correct, it's sine, because x is opposite of our angle. Very good. So this time it is going to be sine of 36 degrees. It's going to equal our opposite side over our hypotenuse. Okay, and again, I put the sine of 36 over 1, cross multiply. Of 36, okay? And then I go over to my calculator, because again, remember, the calculator's got that whole trig table, all those digits memorized. So, correct. Not necessarily where the missing side is. It just, you want to set it up where it's lining up with the ratios. Okay, so for this one, again, we're going 10 times, and I'm going to open parentheses to be safe. And for this wonderful calculator, I got to put in the angle measure first, then hit sine, and then enter. There you go. It's a lot of steps. Okay, at least the calculators here at school are a little bit better. So 5.88 or 5.9. Yes.
I got 5.87.
Okay, which would have been fine, but do you notice the round off? So 7 is one larger. What numbers did you type in?
Oh, I did not round the last one number. I just
Okay,
put.
so
Oh, all right.
You used just when you just didn't round it off, or which way?
Okay, let me just redo it.
Because it is 5.877. You know,
Oh
I
yeah,
mean,
I did that. Yeah, I did that.
yeah, so it's 5.877 and then what, 8 again? So I don't remember. Did this one want us to go to the 10th or the 100ths? I don't remember which way it wanted us to go on this one. Because if it's going to be, I think it was hundredths, so it was two decimal spots. So the 7 would make that 7 go up to 8. So the round off. Did you multiply by 10? Okay, because if we go to now the sign, let me just clear this all out. I wonder if I can just get it to like not show. So I don't want it to show all the memory. Okay, so I just needed to shrink it to make that all go away. It's like too many decimals and numbers. Okay, so the sign of 36, so if I put in 36 and I get the sign, that is 0.5877 on and on. Okay. What we then need to remember to do is that it's 10 times the sign of 36. So then we have to tell it to multiply by 10. And that's where we get the 5.877. Did that answer your question, Ashley? Okay. Yeah, just make sure you put the whole thing in there. That's the only part that gets kind of flumpy around here. All right, so if we take a look at number 4, this time we could actually do this problem 2 different ways because they're giving us both angles. So it just depends on which angle you want to pick to solve, okay? So again, if we identify our hypotenuse, X is our hypotenuse. And again, it just depends on which angle you want to go with. All right, so if we go with 19, then 27 is going to be opposite. So that would be using sine of 19 degrees is going to be the opposite over the hypotenuse. If you decided to use 71, then that makes the 27 adjacent. All right, so anyway, if we were back to cosine of the angle measure, this time though, we were going from the 71 degrees. And we're going to do the adjacent side. And X is going to be, again, our hypotenuse. So, all right, so from there, again, put everything over 1 and cross multiply. Now, one of the things that's going to be a little bit of a teacher or a trick, I should say, it's not really a trick. If your X turns out to be on the bottom, you're going to probably end up dividing to get your answer. And then the other option is if it's on top, you're going to end up going to multiply. So like in this case, both of them are ending up on the bottom. And I just wanted to make sure I was able to show that we are going to be able to get the same answer. Okay. So let's go ahead and we'll cross multiply. And that's the sine of 19 degrees. And of course, this is why I was talking about when the X is on the bottom, we're going to end up dividing. And again, keep it all together. the sine of 19. And that's what we're going to type in the calculator. And I'll move the screen here in just a minute, but I'm going to go ahead and get the other one set up as well. So we'll again cross multiply. Yes, ma'am. Oh, you found the class link? Like somebody put it out there? Yeah, well, that's okay. That's the way that I personally don't. I feel like they should be forced to sign in with their school email. So I will talk to their teachers and stuff. All right, but thank you. Yes, I believe that is the correct answer. Of course, that's going from memory. Let me like real quick look. So clear. So 27 divided by open parentheses. And that one is the cosine. Nope, what did I do? I need to get my other calculator. So.
You forgot your degrees. To put in degrees.
Yeah, probably. Let me clear. 27 divided, open parentheses. And hit enter. There you go. Okay, I caught up with you. Fix it. Okay. All right. All right, so yeah, so it comes out to be 82.93. Sure, no problem. And I apologize for all of the distractions. They're going to end up, I will explain that to the other teachers, Mr. Judd and Mr. DeLong, why we have to keep it inside the district. So in those certain circumstances. So, all right, so that was the 82.9 and no, cosine is not the 82.93. Cosine is the actual value. The 82.93 is what X is equal to in this particular situation. All right, so Ivana, let me go ahead and walk back through again a real quick recap. We had decided that, again, we were given both angles, the 71 and the 19. And so from there, we had two possible options to be able to actually solve for their missing side. And our missing side is the, of course, our hypotenuse. So therefore, we are going to want to use the either, the cosine or sine. So either one can be used. And so in this particular case, again, you could use either one. So if we go with 19, which we haven't even calculated that, but if we go with the 19, then the opposite side is the 27. So that was our opposite side. And then X is the hypotenuse. Okay, and then we're going to cross multiply and solve. Okay, so from there, again, like I said, that's if we use the sine, we would go with the angle of 19 degrees. If we want to use cosine, that's when we would go with the 71. Okay, all right, so again, and that cancels out here. That's what's happening on those there. So then we end up with 27 divided by the sine of 19. And of course, we did it earlier on the cosine. So let me do it for this one. Okay, so now what we're doing is the sine. So, and actually what I've been doing, and hopefully this will help, X actually equals the 27 over the sine of 19 degrees, okay? That was the same thing over here. X actually equals 27 over the cosine of 71 degrees. All right, and that's what we're going to type into the calculator. All right, so once again, going back over here, 27 divided, and of course, since I'm using this little calculator on the computer, we got to do the angle and then the trig function, and we get 82.993. All right, and that's going to be the same thing for the cosine. Okay, so it's not actually that the cosine equals that value, because actually the cosine of 71, let's see, clear. So we type in 71 and cosine. So that is the actual value of the cosine of 32.55, whatever, 0.325558, that whole big, huge number.
Yeah.
Okay, does that make sense?
It makes
Okay, good. All right, sorry. All right, that's what I was like, just making sure. All right, so let's go ahead and look at a few more from that, because then we get into the application problems, and that's a whole nother mess. So, oops. All right. Okay, so for this one, we actually have a 45-45 right triangle. And the only reason we know that is because, again, we have this 45 degrees. So it actually is a special right triangle. But again, they gave us our hypotenuse in this crazy decimal. So nobody wants to mess with more decimals than we absolutely have to. So we're just going to kind of roll with it and deal with it, you know, just like a normal trig function. Okay, so we have the hypotenuse given here, and we have the adjacent side to our 45-degree angle. Okay, and so adjacent and hypotenuse, and again, remember, you know, if it's a sine, it's opposite over hypotenuse, cosine, adjacent over the hypotenuse, and tangent is going to be opposite over adjacent. Okay. So this one being where we have the hypotenuse and adjacent side, what we want to go with is then cosine, right? Okay. What was that again? All right. Okay, so cosine is the function that we're going to want to go with. So the cosine of 45 degrees is going to then be equal to the adjacent side, which is x in this case, over the hypotenuse, which was 11.31. All right. So at this point, then we will place this over 1. And again, cross multiply. So 11.31. And then times the cosine of 45 degrees. So again, we can just go on in and again do the same thing that we've been doing. And we move this out of the way so we can see what's going on. All right, so 11.31 times, and I like to keep my parentheses, 45, and we're going to tell it it's the cosine of 45 degrees, and then hit enter. So 7.99, which would probably round up to 8. Okay. All right, so how's that so far? Oops. All right. So now we have application problems that are kind of coming up on this too. So are we feeling a little better about it? Okay. All right. So let's wrap this one up. We'll go ahead. Let's do 6 here. And then I also have some Get More Math problems too that are already up here on the screen that we can actually look at and, you know, trying to set them up. Mr. Judd did a real good job this week and put out a picture of triangles in real world and how to apply them. So at least that's a good image to kind of try and keep track of things. All right, so again, identify our hypotenuse, and this time we are not going to be using our hypotenuse. Okay, so, oops, okay. All right, so once again, let's remember that the sine is opposite over hypotenuse. Are we having musical issues here, people? All right, cosine is adjacent over hypotenuse, and
Turn it off now.
all right, and that would be opposite over adjacent. All right, so again, we've got no hypotenuse, so we're going to scratch through and not work with sine and cosine. And we're going to then need to be working with the tangent. Okay. From the angle measurement is where we want to determine all of our other information. And so our x is opposite, and 92 is our adjacent side. All right, so that's going to be the tangent of 64 degrees is equal to the opposite side, which was x, over our adjacent side, which was 92. And again, we're just going to put it over 1 and cross multiply. Okay. So x times 1 is x, equal to the 92 times the tangent of 64. Okay. So again, kind of repeat the same process. So 92 times parentheses 64 and a tangent, and hit enter. All right, so 188.63. I lost my decimals there. Okay. Okay. I was just reading the chat, see how y'all are doing. Y'all are still doing okay? All right, cool.
Yeah, comments.
All right. So let's go ahead and start looking at some of these word problems, because the word problems are really where we're going to get tied up when we get to the test. Okay. All right. We had someone else join us, so. Again, if anybody hasn't signed in, please sign in. All right, so, well, let's see, we're gonna have Pythagorean theorem. We're gonna also have special rights, the geometric means, so basically everything we've covered on right triangles. So, and so pretty much sticking with your Get More Math practice is gonna be the key. No problem. All right, so when we are trying to draw these out, and of course, the first couple of examples, we actually drew them out already. And so I'm going to go ahead and do that. All right, so so again, for the first few, we have, you know, again, we've already had it drawn out. And so we're just got to think about what's kind of happening. So Juanita is flying a kite at the park and realizes that all 500 feet of the string are out. So luckily they have that drawn for us, and this is our string. And so that's also going to be our hypotenuse. Okay, and then we want to also determine, and of course they found the angle measure, and we want to know how high the kite is off the ground. So again, from the 42.5, we have the opposite side. So again, going back to our trig functions, where sine is opposite over hypotenuse, cosine is going to be the adjacent side over the hypotenuse, and tangent is going to be the opposite over adjacent. Yes, correct. So we'll want to go with, well, actually it's opposite over hypotenuse, so we're going to want to go with the sine. Okay, for this particular one. All right, so we have, because again, it's the opposite side of the triangle. Okay, so sine of 42.5 degrees is going to equal the opposite over the 500. And again, we want to put this over 1. Yeah, oh, that's fine. You don't have to worry about that part. That I sometimes don't even write the degree sign, but we want to remember that it is an angle measure. So, you know, and so, all right, so cross multiply, and we get h is equal to the 500 times the sine of 42.5. And again, we go back to our calculator. And times, open, 500, and sign, enter. All right, so we should get that the height is 321 point whatever that was, 4. Okay, so that was all for the Mondays in our exciting 50 minutes that we've been together. All right, so again, essentially what you want to kind of do is try to draw these out, and once you've drawn them out, you can kind of start seeing where everything falls together. Let's see, there was one particular one that I know was giving my kids a fit today. And that's this one. All right. So this is, I think, number 4. Yeah. You had a question, Yari?
Yes, how do you get 321.4?
Did I do it wrong in the calculator?
Well, in the question there are only 335, 336, 337, and 338.
Oh, okay. Let me see if I did something wrong in the calculator. Let's get back over there. Oh, I see what I did. I put the ankle measure as 500. Let's redo that, okay? Let's redo that one. All right, so not the sign of 500. Okay, let me clear that. Thank you for catching that. No, I've definitely typed in the calculator incorrectly, so not that. Okay. All right, so 500 times, let's try and get this right this time. So 42.5 and take the sign of it. There we go. Now, does that match the answers?
Yes.
Okay, awesome, cool. All right, sorry about that. Yeah, I totally just wrote down or typed in the wrong numbers. So, okay. Let's look at, so let's see. So I guess once they get in, they just kind of, let's see. All right, anyway, these people are just, it's childish, but it's okay. It's whatever. All right. This was number 4 because we're kind of like short on time, especially after all our craziness today. So this is number 4 on today's learning check on the 9th. All right, and I know this was giving a lot of people a really hard time because we have to take into consideration a lot of different things. One is that we need to do some unit conversions, okay, because we once again have we got inches in one spot and we've got feet in another spot. And so we need to kind of like make sure we get that kind of taken care of. Okay. So, all right. So let's do that first. And we don't want to go to feet, because if we take that 62 inches and divide that by 12 to get the feet, then what we'll end up with is really ugly numbers. And so we really don't want to do that. We want to go ahead and take everything to inches so that it's at least all pretty, values. So, so again, let's go ahead and do that. So 15 feet times 12 to get us into the inches. All right, so we find that that value is 180. All right, so before we get too far along, let's just talk about what's going on in this particular situation, okay? So Tamara is standing and looking at a flagpole. She knows that the flagpole is 15 feet, which we just found was 180 inches, okay? So with that, we have to remember that she's looking at this. Now, let me do something. All right, so the device, the inclinometer, is actually something we used to make them, and it actually has a protractor, a string with a weight, and actually a straw, okay? So she is looking up at this flagpole, and our weight is going to move the string and tell us what our incline is. So it creates two situations. One, when you hold this up, you're actually holding it up at your eye level, okay, which is not on the ground. All right, so therefore we need to take into consideration how tall she is. Okay, so there's a couple of things that we can kind of consider and look with this particular problem. All right, and so one is that we actually have a rectangle that's kind of formed in here, okay? And inside that rectangle, we can actually take values and transfer them to other positions, all right? So if she's 62 inches tall, that means that her eyes are 62 inches away from the ground. And so if this side is 62, then this side over here is also 62 inches. Okay, because we have to think about just a rectangle, okay? Then we have the value of X, and same thing, same principle. We can take that and move it to the other side. All right, and all that's gonna do is just get us to where we're just dealing with the triangle that we need to deal with. Now, to work with that triangle, this whole flagpole is 180 inches, but we only need this height. So we can take the 180 and we're going to subtract the 62 and we get 118. Okay, so that's 118. All right, so now we have a triangle that we can kind of work with. All right, so drawing that, whoops, that's not a very good triangle. There we go, triangle, draw that triangle out. And we have 58.4 degrees is our angle measurement. We've determined that this side measurement here is 118. And we want to know how far away from the base of the flagpole she's standing. Okay, so again, we want to go through and identify. Now our 90 degrees is going to always be with the ground. It's like the building and then the ground. So that's my hypotenuse. So we're not using a hypotenuse. So that means we're not using sine and we're not using cosine. All right, so we are going to use the tangent. And of course, we know that the tangent of theta is the opposite over adjacent. And so that's going to be the tangent of 58.4 equal to our opposite side, opposite of our angle is 118 over x. All right, and so once again, we're going to put that over 1 and cross multiply. And since my x is on the bottom, we are going to end up having to divide. Okay. All right. And those cancel out. And so then we go over to our calculator. 118 divided by, open the parentheses, and again, 58.4, making sure I put in the right number this time. And we did tangent and hit enter. So she is 72.6 6 feet. Oh, wait, actually, now there is one more step in this one because we had to do some conversions. So that X value is, we're not done yet, in other words, because remember, we went to inches. So for this particular problem, she is actually 72.59 inches away from the flagpole. So we need to actually take that number and divide it by 12 to get our feet. And that was one of the things you don't want to forget to do, is go back to the unit that we were originally working with. So it's 6 feet from the base of the flagpole. All right, it's time for me to go. Do y'all have any other last minute questions?
No, thanks, miss. Thanks for the free lesson.
You're welcome.
I'm not even in this school, to be honest.
Yeah, we're figuring that out now.
I got 71.18 in the calculator.
Okay, and so with that, let's see, what did you type in?
118 divided by 10 and
Mhm.
58.9.
Oh, it's 0.4. It's a 4.4.
Oh, I saw it like a 9.
I'm sorry.
I'm sorry.
For the recording, let's see, with it being an hour long, and actually I'm going to edit out all that wonderful jazz we had in the middle. Just being an hour long will take at least a couple of hours for it to process and send me the video to begin with. And then, I'll have to try and work on getting it processed to YouTube so that we can share it, but I'll try and get it out to y'all tomorrow. I think Mr. Judd's been putting putting those links out there in Schoology, isn't he? Or he's putting them on the page?
Schoology.
Yeah, okay. So that's probably what we'll do again tomorrow. And then for some more of these like other problems, because we've got a couple of different types of problems that are going to pop up. And we got to be real careful when you're actually trying to draw them, and make sure that you're getting, and I've actually put these two pictures here for the ladders. And why is because there's slight, like this, like very, very slight, hang on, filing abuse reports on these ones that came on cussing and all that wonderful jazz. They probably don't even know that that can be done. So anyway, just be real careful about where they, like where the angles are. Okay, so I'm gonna just real quickly draw this out for you. So we have a 16-foot ladder against a house. So here's our house, right? So we have this ladder that's leaning against the house. There's my ladder. We know that the ladder is 16 foot, and it is 7 feet away from the building. All right, so 7 feet away. And it wants us to find the angle that the house or the ladder is making with the house. So that means that we are wanting to find this angle up here, okay? Whereas when you're down here, we have the same numbers. We have a building and our ladder is, it's not like letting me type. Where'd my cursor go? There we go. Okay, so then we have, again, a ladder leaning against the building, but we want to reach a window that is 16 feet above the ground. And our ladder is also 7 feet away. But this time it wants the ladder making the angle with the ground. Yeah, these are out of Get More Math. And so for this particular one, it's wanting this angle here. So be real careful what they are asking for. And of course, these are also going to require you to do the inverse function. So for instance, with the first one, we have the hypotenuse. So this is going to be the cosine of theta is going to equal that 7/16. And then you'll do the second, the inverse function of cosine 7/16. Okay, and this one down here, it's going to be tangent because we're not dealing with the hypotenuse. Okay, so that one would be the inverse function of that one. And yes, these were from Get More Math. The second question, sure, and here, Josh, you need to sign in as well. So here's the link for that. And that was in today's learning check. Okay. All right, so one thing, an inclinometer is actually a protractor and a string or a weight and a straw, just so you know what it is. And when you actually tilt, it actually will adjust accordingly. Yari, can you email me a screenshot of your Get More Math question? Since you're not in my class, I can't see your question, but you can email it to me. My email is tsclark2@aldinisd.org, you know, the standard. And you're welcome to email me that picture real quick if you want. For this one, this is the second question out of the learning check for today. And again, you kind of want to think about the fact that we've got a building. And this person, Alejandro, this person's going to be like tall like Mr. Judd because he's 6 foot, okay, is standing 140 feet away. So here's our little person, my little dude here. And he is looking up at the top of the building. So now there's a couple of things that we need to kind of take a register for. First of all, again, we're 140 feet away. But they add in there that his eyes are 6 feet above the ground. All right, so that means that here we're at 6 feet. So just like our problem that we had done a little bit earlier, what you want to do is kind of draw in that imaginary rectangle. Okay, there's like an imaginary rectangle here. And if the building is at a 90 degrees with the ground, then that means that it's also 90 degrees here. So if he's 6 foot tall, like in any other rectangle, we can take those measurements and transfer them from 6 foot to 6 foot. So that means this distance here is 6. And this is 140, so this is also 140. All right, so now the only thing you have to remember to do is don't forget to add the 6 back in to your final answer. Okay, so we're going to want to find this height here in our triangle. So taking our triangle out a little bit. So we have 140. We're looking for this height. And we have our angle measure, which I didn't add in here, which I should have, was 42 degrees. So based on what we have this H is opposite and 140 is going to be adjacent. Okay, so that's going to again be tangent. And we're doing tangent of 42 degrees is going to be equal to the opposite side over the adjacent side, which is the 140. Okay, let me go run over and get that question real quick. All right. And again, what you want to do is set it over 1 and cross multiply. So h is going to equal 140 times the tangent of 42. Okay, so you had one of these ladder questions. All right, so Josh, did that help you out? Okay, great. And don't forget to put it in a degree mode. Yes, it does, I believe, comes out to be, now I'm trying to do it from memory, and that's a horrible thing. Let's see, 140 times. Yes, 126. Now, the thing is don't forget to add the 6 back in. Okay, so we do get that this is 126.05, but we need to add that 6 back in, plus 6. Yeah, whatever it's gonna roll over to. So, you know, and then just add 6 to it. I think this answer was a round off, so you can actually, yes, you're correct. It would have been 06. So 132.06 is going to be the final. Okay. All right, so Yari, here's yours. All right, so you again have that ladder situation. So this time, again, we have a tree. And we have a ladder that's leaning against the tree. And it's a 29-foot ladder. And the base of the ladder is going to be 7 feet away from the base of the tree. And we want to find the angle. Now, this is where we have to be careful, okay, because it's wanting to, the angle of the ladder makes with the tree. So that's actually the angle up here. All right, so that's going to be what's, you know, kind of critical to make sure we identify. That's the angle that they want right there. Okay, so again, it's going to form a right triangle with the ground, even though we know that trees are not directly actually right angles, but we're going to make that assumption because we can. And we're going to want to find that angle with the ladder and the tree. So it turns out that 29 is going to be our hypotenuse, and 7 is our side opposite. So therefore, you're going to want to go back to sine. And you just have to be real careful with that, like the wordings when they throw that stuff in there, because you want to be able to, you know, make sure that you get the right angle that it's looking for. Okay, so for this one, because we're looking for an angle, you're actually going to do the sine. Oh, I see how they set it up. So it'd be sine x degrees is going to equal 7 over 29. Now to solve for that, you're going to do the inverse. And honestly, I have not done inverse on my little calculator here, but that's okay. We'll figure it out real quick. All right, so that's the sine -1. And we just put that ratio value in there. Oh, I had told you I was going to look this up. Okay, so one thing you can do, all right, and this is where they're telling us to use the exact values. But if I look up 7 divided by 29, that gives me that crazy decimal value. And what we can do, and this is where I was talking about the trig tables earlier. So that was sine that we were using. So we want to look in our first column here, and we're looking for that 0.24. So we kind of go scrolling around. Let's see how close we can get. So pretty close to 14 degrees is where it matches up. You can kind of see that right here. And so we're somewhere in this ballpark between 13 and 14, probably. You know, so somewhere like probably 13 point something is what our angle measure is going to be. So let's get back over here to our problem. Yes, you're going to use the inverse of that to solve it. Of course, to haven't ever done it on this kind of on this particular calculator. So let's see. Open parentheses, 7 divided by 29. Close parentheses. And I want, okay, second, sign, enter. So 13.96. So you see we were pretty close to it. And yes, you would use the inverse. And so again, that's going to be the second function. And then the sign and the little -1 will calculate it over 29. That came out to be 13.9. So we were pretty close just looking at our table. Yeah, and it wants it to round to the nearest 10th. So 13.9, I think is, what was it? Oh, 13 point, it's actually gonna be 14, I bet you. Because that one goes all the way out